Today we are still doing G4, which is surface area. So yesterday we focused on rectangular prisms. Today we're going to focus on triangular prisms. But before we can really get started on that, we need to understand the different parts of this triangular prism. Just because it is laying on this rectangle does not mean that it is a rectangular prism. This is a rectangular prism. It's made up of rectangles and squares. Okay, so this one is made up of rectangles and triangles. So just because it's sitting on the rectangle does not mean it is a rectangular prism. It is a triangular prism because we can take this and flip it just like that, and now it's sitting on the triangle base. Okay, so your base here, you have two triangles that are congruent. They're exactly the same. So if you find the area of one triangle, all you got to do is say times 2 here, and you have found the area of both of them. Then you have to know what type of triangle this is to understand the facts about the rectangles. So we're going to focus on 3 triangles today so you can see how these classifications of triangles can benefit you when you're looking at rectangles. So for instance, this one right here. This is a scalene triangular prism. Okay, so scalene is important here because scalene means it has no congruent sides. Okay, so we have a 6. We have a 4, and then over here we have the 8 because this line and this line are congruent, so we have 8 inches. Now, none of these sides are the same. That's why we call it scalene. So what we're going to do is we're going to take all these sides and say, we're going to take each one of these triangles. We're going to say 6, so triangle sides, 6, 4, and 8. So 6, 4, and 8. And we're going to multiply all of these by the height of our prism. Now, height's kind of confusing here because you think height's from bottom to top. But again, if we have our prism sitting like this, we can always turn it like this, and it makes the height. Your height connects the two bases. So we're going to multiply all of these by 10. So 6 times 10 is going to be 60. Now that's going to be the area of this side back here. Okay, that's the 6 by 10 right there. Then we got a 4 by 10, which is the base it's laying on. It is right here. So that's a 4 by 10. So that's 40. Then we have another one that is this really big side right here. This is the 10 by 8. Okay, so we have a 10 by 8, which is going to be 80. All right, so now those are just the rectangles. That is just these sides right here. We now have to do the triangle sides. All right, so your triangle formula is 1/2 base times height, or base times height divided by 2. But here's the catch here. You're saying 1/2 base times height, and then you're saying times 2. Well, if you notice times 2 and 1/2, those are inverses of each other. So they cancel each other out. So if you're going to take half of the triangle and then you're going to multiply it by 2, all you have to do here is just say base times height, and you're taking both of them and putting them together at the same time. Now, if you do that, it's perfectly fine. It's a little shortcut. But if you do that, don't take it and then say times 2 again. When you cancel these out, you are doing times 2. So your base of your triangle is 4, because remember, you're looking for that right angle, and your height is 6. This 8 is what we call a hypotenuse. It's across from our right angle. All right, so then we have 4 times 6. That's 24. Now, that 24 is for both triangles. The area of this one triangle would be 12, and the area of this triangle back here would be 12. Together, it is 24 for both. So then we're going to add up all these. Well, I know 60 and 40 make 100. And then I'm going to say 100 plus 80, that's 180. Then plus 24, you're looking at 204. So your total surface area here is 204 inches squared. Remember, these are inches squared because we're dealing with the net. Okay, you're dealing with it being a flat shape, the outside. This is if you were wrapping a present or something like that. Okay, so this is our scalene triangular prism. Notice we have 3 different rectangles. All right, so now let's take a look at an isosceles. Now, with isosceles, you have 2 sides are the same and 1 side that's different. That's your same, odd, same. All right, so let's take all sides of our rectangle. We have a 4, we have a 6, and we have another 6. It's over here. We don't really write it inside of here only because it can get us really confused whenever we're looking at a bunch of lines and numbers. So this line over here is congruent to this line, so it's 6 inches. So we have a 4 inch, we have a 6 inch, and we have another 6 inch. You could absolutely here do 6 times 2, and well, 6 times 10 times 2. That way you're doing, both at the same time, and that's fine. I like to write them all down, so I'm checking each side of my triangle and making sure that they're all there. Then we're going to multiply each one by the height. Again, a little confusing here, but your height can be turned, your shape can be turned the other way, so you can see that height is up and down. Your height connects the two triangular bases. So times 10, times 10, times 10. So we have this base shape here. That's a rectangle. The base of our triangle is 4, so times 10. So we have that rectangle that's 40. We get another color so we can see it. Then over here we have a 6 by 10. So we have our 60 here. Then we have another 6 by 10 on this other side. It's kind of hard to see when it's invisible, when it's invisibly drawn like this, but you use a little bit of imagination, you'll be able to see it. We have a 6 by 10 there, that's 60 as well. 40 and 60, that's our 100, plus 60, that's 160 for just the rectangles. We haven't done the triangles yet. Now remember, we have 2 of those. So we could say 1/2 times base times height times 2, and those 2 would just cancel out. Or you could find the area of this one triangle and then multiply it by 2. That's completely fine as well. So our base of our triangle is 4. Now remember, you have to find the right angle to find the height. We don't have a right angle shown in this front triangle, but we have one back here. And remember, these triangles are congruent. So your height is 5. So 4 times 5 is 20. Now, again, you could take half of 4 and get 2. And 2 times 5 is 10. So that's the area of one triangle, and then say times 2. Completely fine. I like to go ahead and cancel those out because I know I have 2 of those. All right, so that is with an isosceles triangular prism. Notice we have 2 sames, and 1 odd. So same, odd, same. Then we have our 2 triangles. All right, one last one is going to be our equilateral. Equilaterals are really easy because your 3 rectangle sides are going to be equal. All right, so we're going to look at our triangle. We have a 5, 5, and a 5, those sides, because they're equilateral. So we could do 5, 5, 5 all the way down, or you could say 5 times 3, okay? So that works too. Then you're going to say times 10 on each one of those. So times 10, times 10, times 10. So I don't know why I drew on there. So now we're going to do 5 times 10 is 50. 5 times 10 is 50. 5 times 10 is 50. So this is where we could have said, like we did, we could have said 5 times 3 is 15 times 10 is going to be 150. So our rectangles would equal 150. That's only the rectangles. We still have 2 triangles to look at. All right, so with our triangles, we're going to do 1/2 base times height times 2. Okay, 1/2 base times height times 2. These half and times 2, they cancel each other out. So we can just mark those out. Our base is 5. Find that right angle to find the height. Our right angle is 3. It's back here. Okay, so there's our 3. So the area of both triangles together is 15. So now we're going to take our 150 and our 15 and add them together. So it gives us a surface area of 165 inches squared. So remember, surface area is the outside. Also, another thing to remember about this lesson is it all depends on what type of triangle you have. If it's an equilateral triangular prism, all your sides are the same. If it is, let me pull out the other one. If it is a scalene, all of them would be different, just like here. And then if we have a isosceles, you have 2 that are the same and 1 that would be different. Make sure that you understand we can do 1/2 base times height times 2, and those 2, the 1/2 and the 2 cancel out. Or you can find the area of 1 and then multiply by 2. That's fine. But you have to make sure you have all 5 of your faces added together when you're done with this shape.